Solving equations with variables on both sides. In this lesson, we're going to see that our variables or numbers are going to be present on both sides of the equation. In order to solve these equations with variables on both sides, we need to collect the variable terms on one side and then the constant terms on the other. What that basically means is getting the variable or x's or letters on one side and then the numbers on the other. In our first example, we're going to have 15 minus 2x equals negative 7x. What we need to do is make sure that our x's move to the same side of the equation. I'm going to look at this 2x because I don't want to leave one side of the equation blank. Since it's minus 2x, I still do the same inverse operations, and I'm going to add it to both sides of the equation. The negative 2x and the plus 2x, positive 2x, cancel out, so we're left with 15 on the left side. Negative 7x plus 2x is negative 5x. Now we have a simple one-step equation. I'm going to divide by negative 5 to get my variable by itself. X is equal to negative 3. Although we know this might be correct, we still have to check our answer to know for sure. I'm going to plug in negative 3 into our original equation. 15 minus 2 times negative 3 equals a negative 7 times negative 3. This minus 2 is the same thing as negative 2, so negative 2 times negative 3 is 6. We have 15 plus 6 equals a positive 21 when we have negative 7 times negative 3. 15 plus 6 is 21, so we have 21 equals to 21. We know our answer is correct. In our second example, we have 3 times 5x plus 2 equals 15x. Whenever we see the parenthesis, we know we're going to distribute this 3, the outside number, to both terms on the inside. By doing that, we're multiplying the 3 to everything inside. 3 times 5x is 15x. 3 times 2 is 6, and we set this equal to 15x. Now we need to make sure our x's are on the same side of the equation. I'm going to subtract this 15x because it's positive, I have to do the inverse, to the other side of the equation. However, when we do this, both sets of terms cancel out. Because it cancels on the right side, we have 6 is equal to 0. That's not a true statement. So this solution is actually no solution. This can happen to you, and this means that there's no number you can plug in for x to make these equations equal because they weren't equal to begin with. In this example of negative 2 times 4y plus 1 equals negative 8 minus 2, what you have to do is distribute immediately first. We have a negative 2 times 4y, which is negative 8y, and the negative 2 times 1 is a negative 2. When we set this up, you see that our equations are absolutely equal. We have negative 8y minus 2 net equals negative 8y minus 2. We still continue, however, and we're going to add this 8y to the other side to get our variables by themselves. When we do that, however, they do cancel out again, and we're left with negative 2 equals negative 2. Yes, our variables canceled out, but our answer is going to be different from the previous problem. These answers are actually correct, and negative 2 does equal negative 2. When this happens, you have an infinitely many solution. That means any number that you plug in for y will work in this equation. The equations are already equal to each other, so that means absolutely any number you plug in will work, as opposed to the opposite in the previous problem where no solution would work. Now we're going to apply our knowledge with geometry. These circles are identical, the same. What is the area of each circle? If they're identical, then that means they are the same size. We need to figure out what x is first before we find out what the area of each circle is. We need to set the radiuses equal to each other. The first example has a radius ready. The radius is halfway across a circle. When it's all the way across, like the second part, or the second circle, that's the diameter. To find the radius, you're just going to cut it in half. Half of 4x is 2x, and that's now our radius. We're going to set both of them equal to each other since they're equal anyway. So we have x plus 2 equals 2x. Now we're going to solve for x to see what our radius is on each circle. I'm going to subtract x from the left in order to get our variables on the same side. We're left with 2 equals 1x. The x on both of the circles is the same as 2. So to find the radius, we're going to plug in 2 into the radius on the left side of the equation. 2 plus 2 equals 4. If you also wanted to plug it into the right, 2 times 2 equals 4. This is just further proof that the area of each circle are going to be identical because the circles are identical. The area of a circle is pi r squared. So we're going to find out what our area is. That's the ultimate answer for our question, not what the radius is, but what the area is. The radius we found was 4, so I'm going to plug it in. Area equals pi 4 squared. 4 squared is the same thing as 4 times 4. Our area is pi times 16, or 16 pi, and that is our answer. In this next example it says, what if the diameter of the purple circle is 3x instead of 4? What that means is when our radius is cutting that in half, it's 1.5x instead of 2x. When you find the radius of the first two circles, you're going to put x plus 2 equal to 1.5x instead of 2x. When you solve, we subtract x from both sides to cancel one side out. We have 2 equals 0.5x. Now we need to divide by 0.5. While we do that, our radius is equal to 4. Now I said radius, but I was mistaken. X is equal to 4, and we still have to plug it into our circles. As we did earlier, I'm going to do x plus 2 or 4 plus 2. That means that our radius now is 6 instead of the usual 4 that we had in the last example. When I find my area of the circle, remember area is pi r squared, we're going to plug in 6 for r instead of 4. The area of our circle is pi 6 squared, or 6 times 6. The area is 36 pi, and that is our answer.